Okay, no one say anything mean. Oh, I said something mean. Just kidding.
All right, we are live. All right, going straight to the meeting quiz thing.
Yes.
Practice then.
Alright. So, I guess I'll start us out this time. Number 2, given a 90% confidence interval of 45 over 105 for mean heart rate, which of the following is the best interpretation of the confidence interval level? So, we are 90% confident that the true mean of the heart rate is between 45 to 105. There's a 90% chance that the true mean of the heart rate is between 45 and 105. 90% of all people have their heart rate between 45 and 105. There is a 90% chance that the sample mean of the heart rate is between 45 and 105. It's the last one. That's my thought.
It's the last one?
Yeah, because it's of the sample mean. So it's only 90% of that sample mean, because there's still that 10% where it's not within that.
Okay.
Or is it that one, or is it we're 90% confident that the true mean is between those two?
I remember the homework assignment saying something about being confident. Let's see if I can. I'm gonna see if I can find it real fast.
I think it is the confident, that we're 90% confident that the true mean heart rate.
No problem, I just got it here.
What you working on?
I'm working on the GT for 26. It's just basic math without the use of the calculator. I'm trying to figure out what I did wrong.
Okay.
I have to get an 80 on this assignment.
I feel like this is going back.
Okay.
Okay.
And it's due tomorrow.
Okay.
I've been working on it, the last few days, but I keep getting certain ones wrong, and I can't figure out what I'm getting wrong.
Okay. I actually have to go. My shift ended 15 minutes ago. Okay. But is it okay if I go grab someone for you?
Yeah.
Okay.
No problem. Thank you.
Oh wow! It has that right there for the review question, number 1 in the book. So.
Wait, what? Where?
If you look at the book, the question I just read is the exact same question in the number 1 in the review. And so, does it give us the answer? Let's see. Researchers.
Are there answers?
I think they're all the same, and I don't think we did get answers.
Oh.
Oh, where was that? Was that the preparation assignment? I thought it was the homework assignment. Oh.
I don't know, it just sounds right to me. But also, I guess we are 90% confident that the true mean of that can make sense too.
Well, no one's actually been able to this help you. No, you're fine. I don't have.
Well, we can go back to that one. I mean, or I can volunteer.
Okay.
It's fantastic that we're stuck on the first question already.
Oh, this is. Man, I know. Because you know you do the right thing. It's been a long time.
Okay. I can read the next one. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go-no-go stimulus of males, to go-no-go stimulus, that makes sense, differed from that of females. The researchers randomly selected 20 females and 20 males to participate. The go-no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. Okay. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? So the requirements for a confidence interval are, has to be normally distributed, and the confidence interval
It seems like all of them were like normally distributed, simple random sample,
random
and
sample.
a large sample size,
Yes, that's right. That says one.
right?
Mm-hmm, that's right. So we've got the answers. Yes, the distribution of the mean for each sample is normal since the researchers can apply the central limit theorem. And so there's 35 in their sample group, right?
Yeah.
Or does it have to be for each group?
Aren't they testing them all for the same thing?
Yeah, I think so. So we could say, so the first one is right then, right? Since it's a large sample size, the central limit theorem applies and the distribution is normal.
Yeah.
I would say that because it doesn't say anywhere about the distribution being normal,
Yeah, it doesn't.
but the sample size is large, so that's what I would say yes. That one.
Okay. So A.
And I looked at my notes for the confidence interval, and we are whatever confident that the true value between lower and upper limit. Those are in my notes.
Okay.
So that first one would be we are 90% confident that the true mean heart rate is between 45 and 105.
Okay. So and for the third one, it also says right there that it's approximately normal.
Oh, there it is.
So yeah,
Oh,
because they looked at the QQ plot.
okay. You're right.
Both samples.
So that's the stronger evidence then, right?
Mm-hmm.
So it should be B.
Mm.
Isn't that what we pick first?
Because it says it's approximately normal.
Mm-hmm. I think since they checked it, that seems to be stronger evidence.
Then let's go with that one.
Oh.
So did we go with A or B?
B.
B. Okay, I'll take 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Confidence interval for mu when sigma is known. Confidence interval for mu when sigma is unknown. Confidence interval for the mean of differences using dependent samples. Confidence interval for the difference of means using independent samples. Well, I'm going to say we don't know what sigma is, so it's probably not A, right?
Right. So we have to, and the samples seem to be are independent. So it's not C.
Right.
So are we looking for differences of means?
Yeah, because it says
Yeah.
right there it says interval. Let's see, the confident interval to determine the difference of the means is significant.
Right.
So it would be the
The last one.
Yeah, the last one.
What's David doing over there? Flagging somebody down?
He's like, come here.
No, this way, this way.
Sorry. I just have to like put it on mute for a little bit when tutors come by,
Yeah.
so you guys don't have to hear other people's conversations.
All right,
But I was just
you're up.
asking him. Just asking him if there's any stats tutors. Hopefully there is one, otherwise we're in trouble.
It's your turn to do 5, David.
Oh, sorry. Okay.
Get the last
So-
one.
What did you guys talk about on number 4? Is it
We decided it was confidence interval for the difference of means using independent samples because it does to determine if the difference of the means
So
is
there's
significant.
someone here. Her name is Keely Smith. She's got brown hair and glasses. Walking around.
Okay.
So you know a stat. Or just has to know if you're that. So yeah, it's a stat.
okay? Okay, I'm sorry.
You're good. You're up
Okay.
on 5.
Okay. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be those two numbers. Which of the following would produce a confidence interval with a small margin of error than this 95% confidence interval?
Smaller margin of error.
Small margin of error.
So, what's the rule for that? I think I wrote that down last night. The factors that influence the confidence interval width. Is that pertinent?
Which of the following would produce a confidence with a smaller margin of error? Wouldn't it be? My best guess would be C. And if it's not C, then maybe none of the above.
I was thinking there was something about
Savings account.
I was kind of leaning towards C.
Yeah, because none of these, at least none of the two answers see. The first two answers don't really
No,
seem.
but the larger your confidence interval is, the smaller your margin of error.
So then it would be that one.
Compute a 99%.
Yeah, but also if you do have a bigger sample size, that also decreases the margin of error, doesn't it?
Yeah.
So if they were to go up to 90 from 30, that would also decrease it. So what would decrease it more? Oh.
Whoa, there's a question. Well, because I think it would be obtain the balances of 90 bank customers, because when your confidence interval gets too large, you switch from number 1 error to making chances of making number 2 error. Or it's not number 2, what do you call it? Type 2. From a type 1 to a type 2. So I would say B.
Okay.
All right. Sounds good to me.
If you.
Are you frozen, David? David's frozen. Did you learn how to make a fire, Dustin?
Yeah, it was a nice refresher. I was able to do it multiple times, and then go around helping some people that weren't quite getting it.
Yeah.
So right now I smell like smoke, which I love.
It's a bonus, right?
Yeah. I got back, and then I'm like, oh, Albertsons is having their buy one get two free sale, so I went and bought a bunch of shrimp.
Oh, cool.
That's why I was a little late. I'm like, if I wait, they're gonna be gone. So
Oh.
I got like 12 bags of shrimp.
Oh, wow.
Oh, my kids would love to come to your house.
Oh, yeah. Last time they had that sale, I got like 3 racks of ribs, 3 pork loins, and then 6 bags of shrimp, and it was like $200 worth of meat, but I got it for $68.
Whoa.
Oh.
Crazy.
Whenever they have those sales like that, I jump on them.
Yeah.
Sure.
You know what? My VMware just crashed, and David's gone.
Oh,
That something happened with the school system.
that's probably it, because they've been having issues with iLearn and with registration all day.
Oh, crap.
Yeah, my VM just crashed too.
Well, iLearn's still up, hopefully.
Oh, well, let's hope.
Mm.
Let's see.
They still haven't added the one class that I need for graduation yet. They're
I-
supposed to have it, but it's not showing on registration at all. And they'd said they'd fix it by today, or they'd said they'd fix it by Wednesday. So
Oh, well, the 2 teachers I wanted for my classes were both full, so I'm on wait lists.
oh,
What are you taking next semester, Amy?
Taking Psych 302.
Me too.
Oh, who are you taking it with?
I forget. Shari told me who to take. Who did she say?
little
Was it-
hint. If you
Was
know
it
people,
Bushwell or Bush something?
That sounds right.
That's who I'm waitlisted for.
That's probably it because she said that that person was filling up fast.
I kind of forgot I could register today, so I didn't register until later, and then I was like, dang it! But I'm like the second on the wait list, so I think I'll get in.
Yeah, it's Bushman.
Yeah, that's who. And then I'm taking Family 360.
360.
hmm
Which one's that?
That one was, I think it's Family Stress and Coping. I think that's the one.
Oh, that's a good one. You'll love that.
So,
Yeah, I've done that one already. I've got a bunch of communications classes I've got to take.
oh, fun.
Yeah, hopefully. Well,
All right. Is David back? Was he back? Oh, he's not back.
I think the computer at the school is a problem.
yeah.
Should we
I have
keep
to-
going, or should we wait?
Probably keep going, because if the school system is messing up, then it's only a matter of time before it leaks over to iLearn.
True, true.
Get as much distance as we can. Okay, I've got to open it up in this window because I had it up on the VMware. David back? I hear the background.
David's
Yeah,
back.
sorry. That was weird.
Yeah, we all lost our connection to VMware. So.
Okay. So it wasn't just me, hopefully?
Yeah. It was everybody.
Okay, good. So,
So we decided that was B, right, for 5.
yeah. So did you guys hear me before it got disconnected about me getting the tutor?
No?
Okay, so if you guys want, we can star some problems, and then when we're done with all of it, I can go to a tutor and double check the answers before we submit it.
Okay.
All right.
Whose turn is 6?
I don't remember.
Okay, I'll go. Factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate true mean length of the shaft. She randomly selects 4 drive shafts made at the factory, measures their length, and finds the sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. So we're going to use a formula since we do know the sigma or the standard deviation. Let's see, then we use
It's the X bar plus or minus the Z critical Z times the standard deviation over the square root of n.
that's it.
So
What's n?
X bar's the 1,000,
Yes.
and Z we have to figure out.
Oh, 4.
The critical Z, that's, remember back where we did the, like, put 95% in the normal probability applet and it gives you the critical, or it gives you the...
Oh, I have that written down right here. So we did it for 95%.
Oh yeah, that's right.
So this
Yeah.
is 1.96.
1.96
Yeah.
times 2 over square root of n is, this has 4, right? So we're just assuming that's all normally distributed and whatever.
Well, it says normal distribution.
Okay, you're right. It does say it. Thanks.
So let's see. So we got X, which is the 1,000, right?
Mm-hmm.
Then we have Z, which is 1.96, and we multiply that by the standard deviation, which is 2, over the sample size, which is 4, right?
Yep.
So I got 1,007.84 for that one. And then we got to subtract it and get another one. And I got 992.6. So do any of those match?
No, that's different than what I got.
That's different than what I got, too.
So I did 1,000 minus 1.96 times 2 over, oh, I forgot to put the divide sign. That would make sense. Let's see. Okay. So that gave me 998.04 for the subtracting. 1,001.96 adding. So it would be the first one, A.
Beautiful.
That's what I got.
Yep.
I can still use a calculator.
Yay. I can take 7 to assess the or is it, did I already go once or twice?
No, I think it's back to you.
Okay. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean mu and standard deviation sigma equals 0.01 grams. How large should n be so that a 95% confidence interval for mu has a margin of error of plus or minus 0.0001? Okay.
So we need to figure out what mu is.
We know that one. Oh wait, no, we don't.
No, it's unknown.
So to figure out, we need to figure out standard of error, the margin of error.
Oh wait, I know this one. This is the it was in the same place as the last one. Hold on. Oh, so it's n is equal to, because we're looking for n, right?
Yeah.
So n is equal to critical z times the standard deviation over the margin of error, and it's squared.
Oh, and squared.
Okay, I see that. Energy over m. So the margin of error. Okay, cool.
So the margin of error is the 0.0001.
Yeah.
And then D
Would be.
at 1.96 again, because it's 95%.
Yep.
And that was the sample size formula, is that right?
Yeah. Sample size.
Yeah, because we're looking for n. And then the standard deviation is 0.01.
And then over m, which is the 0.001.
Yeah.
Okay, I got 196.
Did you square it?
No, I didn't.
And
Where's the square button?
what is C? Is that 95%?
Okay, I squared it now.
Yeah, that's the critical Z, so that's the 1.96.
So then I got.
I don't understand how these numbers get there, but
Yeah, I got 3 or C.
that's what I got.
Got C.
Yeah.
Okay. Amy,
I'm gonna get a bag of gummy bears in one sitting.
All right. The mean area of several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses are
So the new would be okay, yeah.
it's B, right?
Yeah, it's
So,
not 1250.
Yeah, so the null would be that they are the same.
that they're
No difference.
Mm-hmm.
But it does say they think they're
Oh
small.
wait, they're smaller.
You're right.
Yeah.
You're right.
Yep.
They do get
So
small.
wouldn't it be the first one?
B.
Yep.
The
Oh.
last
Yep.
Okay. Right. Okay.
You're so right, Amy.
Amy knows.
She knows.
Knows things.
Me only
She's trying to
knows
be humble.
your group.
You want to take my test for me?
I didn't do so good on the first one. I'm not sure you want me to take it.
You did better than I did. The teacher did some pity points for me, so.
Oh, good. That's good.
All right, I'll take the next one. In the statistical test of hypotheses, we say the data are statistically significant at the level of significance if is it the first one? Or, oh wait, does it have to do, no. P-value.
That's with the p-value, I think.
Okay,
Yeah.
So we're right.
so if the p-value is larger.
Yeah. So if it's low, you reject the null. But if it's larger, then you have something significant. No, wait.
I think you.
Is it the other way around?
if it's low, reject the null. So p-value is
Which
the
is
probability
it's
that's statistically extreme, the one you got, assuming that is true. A p-value is calculated by finding. Okay, that doesn't help us. Sorry. I really need to organize my notes better.
yeah. If the p is low, reject the null, which is it means that it's not enough evidence, insufficient.
Well, the null we always assume is true unless there is something significant so that we reject it.
We say that data are statistically significant at the level of significance. Wait, I feel like this is a trick question. Is it the first one? Because usually, don't most
Well, A
questions
can be
use...
different. A can change. You just have to decide on what A is before you start your analysis.
Oh,
But it
yeah, right. Okay, yeah, then it is p-value is larger.
So.
Yeah.
So in my notes,
Okay.
probability of a type 1 error equals the level of significance, and a type 1 error rejects the truth. If that helps.
Now that's different.
So it's D, right?
Well, it's either D or B.
Statistical class data are statistically significant.
So why don't we remember this one and get a thing at the end?
Yeah, that's a tutor question, I think.
Okay.
Alright, I've got 2, 5, and 9. Star.
1 and
Speed.
2 and
And 3, and the whole thing. Okay. Who's up?
Dustin.
Oh, sorry. Right. A group of statistics students want to determine if a student in some apartment building get better grades than other students in other apartment buildings. They collect GPAs from anonymous random sample size of 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question? Well, there are multiple samples, so I would say yes. Because it's if there's 3 or more samples, then you use ANOVA, right?
Right.
Let's see. So it's one of the top 2. Let's see. Yes, it is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variance is nearly equal. I would say that one. The other one is yes. They have a total of 60 GPAs in all, so they can apply it to the central limit theorem. So I'd go with the first one because it says it's bell-shaped. There's no outliers, so it's equal. That's good enough evidence. Number 1 is right.
I would agree.
I concur.
Let's see. My dog saw a squirrel.
Squirrel.
Yeah. So, me?
Yeah.
Yep.
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. So that's the null. Okay. So in an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample size is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it's determined that the new treatment does not increase the mean survival time in a population of all patients with this particular type of cancer. The researcher has rejected the null even though the null was true, right?
Yeah. So that's
type 1.
Yeah.
Right.
I think the other ones are just fluff to confuse.
Yeah.
Yeah. I
And
agree.
type 2 error is when you accept the null when it's not right.
Right.
Okay.
All right. Number 12. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? Different. So if type 1 goes down, then type 2 goes up.
Yeah.
So it would be the last one.
Yeah.
Yep.
That makes sense to me. That's saying something.
All right, David.
Okay. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams mu and a known standard deviation sigma equals 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. So, at the 5% level of significance, you can conclude that you should.
Okay. So this is, we have a standard deviation given to us.
Yeah.
So we can solve for X or for Z. For Z.
Mm-hmm. And 5% level is just 0.05. Sure, little buggers.
So this is when we need to do the Z one?
Yes.
What's
So we got X bar minus M over standard deviation divided by the square root of N.
That was so long ago. It's like
yeah?
going back.
So that was
Under the step 2 hypothesis testing if the standard deviation is known.
So you said it's X bar minus
X
and
bar,
then
so it'd be 1.53 minus 1.5, and then you divide that over the standard deviation, which is 0.17, and then you divide that by the square root of N, which would be the 100 cigarettes. That's the sample size.
What goes on top of the fraction?
So the top of the fraction is X bar minus M over standard deviation divided by the square root of N. That's what it looks like. So, and I got a 0.647 or 648, and so that is obviously bigger than 0.05. Let's see.
Sounds like it might be D.
Yeah, because it's not.
I kind of wish they'd done some of this, like putting everything together before the test. Like we've learned it all separate, and then it just seems like this week it's like, okay, now figure out how to do it all at the same time.
It'd be nice if they told us what section each question is from.
Yeah, it would. Now I'm not sure. So what did you get for that answer again, Dustin? I just got mine.
I got 0.6476, and it keeps going on.
Oh. I got
0.76.
it was 1.53.
Minus 1.5
Minus 1.5.
over, so I just did another dash mark over 1.7 divided by the square root of 100.
Was it 1.7 or 0.17?
It's 0.17. Is that what I put or said? Let's see.
You said 1.7.
Oh no, yeah, I put 0.17.
Okay.
So sometimes I read things wrong.
Right. Well, then how did I get it? So that goes to be like 0.03 for the top, 0.017 for the bottom.
And that gave me 1.76470 something.
Yeah, that's what I got too.
Let's see. Maybe if I try this.
Wait, what did you guys get, Amy and Tara?
We got 1.7647.
Yeah, I got that too.
Okay, so obviously
Oh, but wait a minute.
let's see.
I feel like there's another thing that we have to do.
We've got to get the P. So that gives us,
So how do we get the P?
then you go to the applet, right?
Oh, yeah.
That's use the applet. Yeah, it's right there.
Applet. Yeah, that's why. Good job. Good job, Amy.
So we put in, that was our Z-score, right?
1.76. Or, yeah, 1.76. And the alternative is that it's greater, so then you would only shade the right side, right?
Right.
So
I got 0.0392.
I've got 0.038.
That's, I have 0.0389.
Oh,
Oh, yeah, it rounded my numbers. That's why I didn't keep it.
oh,
Even though I didn't put them in rounded.
oh,
So
yep,
that's
you guys
still-
are right. Yeah, when I put in 4, it did 0.0389. Okay. So then, since that's lower, then we reject it. So that'd be D.
Yes.
Okay.
back to me.
Yup.
Okay. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 each for each group and test if those means are different. What is the correct statistical procedure? So we have two groups of 100, and they're related. So I would say a paired sample t-test.
Are they related?
I don't know if
Yeah,
they're
I don't think so.
They're related because you're just looking at the wages, right?
Well, it doesn't have to be like, you don't have to keep Dave and Sarah together. You just want like all the boys against all the girls. So,
Yeah, like Dave doesn't affect what Sarah gets.
yeah.
Oh, okay.
not a before or after.
So it's independent samples?
Yeah. "15. Educator is interested in academic achievement by males and females in similar academic support systems. She decides to use brothers and sisters raised in the same home." So these ones, you have to stick together. Because Dave and Sarah have to stay brother and sister. So, furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? Dependent, because if you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study.
Mm-hmm.
Yes.
Amy Bobby me.
All right. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open the data file, dissolved organic carbon. Use this information to answer questions 16 and 17.
Oh, good. The software can do the work for me.
It'll let me open it.
What the? That's weird.
Let me open VMware now.
Yeah. I did have this open and ready to go until it crashed.
Yeah, I did too.
Luckily, I am at the computer, so hopefully you guys can just see it.
Oh, you've got it right there.
Yeah, I'm using my laptop and the school computer.
Oh, good.
Look at how smart you are.
Still didn't stop the internet from crashing. Okay, so in this one, we're just going to use analyze, right? Descriptive statistics and explore.
Yeah.
Because we're looking for the confidence interval.
Of the 4 types of confidence intervals listed, which one is appropriate for this situation?
Okay, can you guys see that? I don't. Is that too small?
I can't read it. I can.
Let's see. Ah, I should have planned it better. Should use my phone instead. Actually, you know what? I think I might actually do that.
You again. Can you read it off for us?
Yeah. So I'm reading the lower bound and the upper bound, right? Yes. No.
Let's see.
Oh,
Or,
that might be for question 17, actually.
yeah.
Yeah, actually it is, but so it's asking of the 4 types of confidence intervals listed below, which one is appropriate for this situation? So when when sigma is, it's unknown, right?
Yeah, we don't know sigma.
We're
Are
not
they
using.
dependent or independent?
But SPS gives us the sigma, doesn't it?
Yeah.
Yeah, it does. Here's the weird thing: is when I popped this thing up, it only showed one number. Like it only showed one column of information, or one row.
Like it doesn't give you the lower bound? What do you mean
Well,
by
it
what?
does.
No, it's only one set of data because I just got it pulled up.
Oh, is it one thing? Okay, then I'm not going crazy.
No, so it's only one.
So it wouldn't be the last 2 because there's no other samples. There's only one. There's only one, right?
Right. Just saying the carbon level in the field, not compared to anything else, just what is the carbon level in the field. So I think we're starting out with sigma being unknown.
Yeah, I think it's B.
So we couldn't do it by hand. We had to. The only way we could get it was through that SPSS. So what did it give us for our confidence intervals?
I got for the lower bound 11.168 and then 15.217,
Okay.
which is the last answer. Did you get that too, Amy?
Yes, I did.
Okay. Cool.
Okay, let's move on.
So that's 11.52 over 14.865.
Wait, what?
Now it's 11.168 and 15.217.
All right, thank you.
Yep.
Whose turn? David?
Dustin's, right? David, then Dustin.
Oh, I thought it was the other way around. All right, a random
Sorry.
sample of Hummers for sale, Los Angeles and New York, were taken from a listing of Cars.com. We want to know if there are different means listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the listing prices between the two cities. Open data file, use Hummer, LA, and New York. Use this information to answer 18 through 19. So, let me try and reopen VMware.
What data is it? Hummers?
Used Hummers. Ah, it died again. I had it open and it died.
Oh, mine's still open.
Really?
Yeah.
Mine has the blue square of eternity.
Forget that whole figure 8 thing. It's the blue square. That.
Okay, what are we looking for?
The Hummer, used Hummers, LA and New York.
Okay. I got it pulled up.
Okay.
Same.
They want us to use a 95% confidence interval to determine the differences in prices between LA and New York. So, hey,
Oh, so they want us to compare?
let me read.
Oh, so now we have to decide which of the confidence intervals is appropriate for this situation.
Yeah.
No one cares. Yay!
Only an idiot would ask a question like that. That's the correct answer.
Or a nerd.
I guess if you're a Hummer lover, you want to know the difference.
Okay. So we don't know sigma.
If you're a Hummer lover, you can afford to pay someone to do this for you.
That's true.
So, which
think-
one is appropriate?
I think they're independent, right? Because we're not putting
Yeah, because they're separate cities.
we're not putting specific Hummers against each other.
Right.
So
So
they're independent.
So,
would that be the last one?
yeah,
Difference of means, definitely.
using the independent sample.
Mm-hmm.
Okay. Okay, so is this one where we need to... Do we have to transform the...
Yeah.
Yeah, you need an upper and lower bound.
Oh, we do?
Or do the automatic recode?
Yeah, because it has. Well, I'm still waiting for SPS to pull up now. But
Yeah.
yeah, if the columns are, if they have non-numeric information in the columns, then you'll have to do that recode.
So which one am I doing?
Is
So
it
you have to-
name?
You go to transform,
Automatic recode.
automatic recode, yeah.
And I move the grouping variable. Which one is what? The city?
Yep,
It's the city.
is
that
the
right?
grouping variable.
Oh, because we're looking for the two cities. We're comparing the two cities. Okay.
Because the
So
grouping variable is not ever the ruler, right?
Well, it's the non-numeric, so
Yeah, non-numeric.
Well,
Okay, so
Well,
that's
the problem is there's like 10 non-numerics.
oh really?
Yeah.
yeah. There's year, make, model, seller, body, color, source.
Oh,
I
yeah,
don't
we're
think-
well, we're grouping by cities. That's how we're comparing. So that's the one.
Yeah, I think it's just the cities that you're worried about.
Okay, and then we're comparing means, right?
Mm-hmm.
And we're independent samples.
Yep.
comparing.
Could you screen share, Amy, so I can see where you're
Oh, sure. Sorry, totally forgot about that.
bopping around too?
Were you?
I'm gonna
playing
be a
peek-
pro at screen sharing. Just so you know.
The best dang screen sharer ever.
I hope this is the right one.
So what's going on the test variable? Is it price?
Test variable. Oh yeah.
Can you see it? Did I do it right?
Uh-huh.
Okay, so the test variable is what? The price?
Yeah. Yep, price.
Yep, price.
Is that right?
That's what we're worried about.
And then the grouping is the one I recoded, right?
Huh?
Yep. And then you just put 1 and 2
Oh, yeah.
for the defined groups.
Okay.
Well done, Amy. Well done.
Thank you. Okay, so what are we looking for now?
The upper and lower bound.
And it's the bottom that we use, right?
Well, what's it say on the far side again?
Over here?
So there's equal variance assumed and equal variance not assumed. So let me look at the question again. I guess we're assuming the equal variance, right?
Wait, I feel like we're always supposed to do the bottom. Where did I hear that?
Oh, we did the bottom, right? Use the bottom.
Well, we've done the bottom in the past, and it's worked out.
Yeah.
So do we have that for negative 423.158?
Yes.
5,417.256?
Yep.
I just
Yep.
got rid of the decimals, right?
Then what?
Yeah, we have negative 423 and then 5,417.
Let's see. So we did agree on mu is unknown, right? For 18 as well.
We went with the last one.
Yeah, we want to see.
Oh, that's right. Sorry. Independent samples.
Yep.
Yeah.
Okay. But number 16, we went with mu is or sigma is unknown.
Uh-huh.
Yeah.
Okay.
Alrighty. Okay, where are we? Whose turn is it?
Not mine.
Probably mine or something.
All right, Tara, go.
Okay, many studies have suggested that there's a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats, because they jump all the time. There were 3 groups. Rats were selected at random for 3 groups. A control with no jumping, a low jump group, a high jump group. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The rats were selected at random for the 3 groups. Wait. At random? For the 3.
So they have how many rats? 8.
So they're just restating that.
Yeah.
Yeah.
Okay, researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. So A is the 0.05 level of significance. Open the data, use this information. So it's going to have to be ANOVA because there's 3 groups. So that answers 20.
Well, yay, that one was easy.
Yeah.
Exercise,
I like problems.
bone
Problems.
density.
But
Okay.
we'll have to open
Yeah.
SPSS again.
As long as I don't have to do math.
Yeah, as long as it does it for me, I'm okay.
Bummer when it doesn't open the Hangout in a different window. So I can't see you guys and the page at the same time.
You should be able to see like a.
There's a move to a new window option. What if I do that? Yes, that's what I need. Okay.
Okay, do you want me to do my screen sharing thing again?
Yes,
Love
yes.
that.
All right, here it is. You see it? Did I do it right?
Yep.
Yep.
Okay. All right, where are we going?
Are we going to transform first?
Yep, need to recode it first.
Okay.
Recode treatment.
Recode.
Or is it? It looks like it's already recoded. It's already recoded.
The rat bone looks like it is. Does that mean we have to recode the treatment?
Yeah. Yeah, we need to recode the treatment. Is it missing values? It doesn't actually give us the bone density values?
Well, the bone density doesn't have like a little A
It's
on
already
it,
been recoded.
and this one does. The treatment does. And so when we recode it,
What are we looking for?
And the problem says we're looking for the test statistic. So we're looking for the t value.
So we go to the compare means.
Yep.
ANOVA.
Oh, we don't have to do that for ANOVA?
Well, I don't know, because now I don't have a factor. Let me go back. Transform. And this is the one, right? Or not? Or is it the treatment that I'm recoding?
I think it's treatment because the rat bone doesn't look like it's got. The rat bone looks like it's already done.
Yeah, the rat bone's numeric. The treatment's not.
All right, we'll do that one.
So, is the rat bone going in the dependent?
So I'm going to analyze and the compare means, right?
Yeah.
And the rat bone is the dependent, and this is the factor.
Yeah.
We're looking for a t value.
How about an F value?
An F value?
There's not a T
Oh, okay. No, it is an F value.
because F is 7.978.
Okay.
Is that a
Is that an option? Let's look.
Yep.
7.978. Yep.
well, good? We did it right.
Mm-hmm.
And then
Okay.
we have to go on to the applet.
It should. I think it gives us the p-value is.
Isn't that the sig,
Oh,
That's
you're
big over
right.
there.
You're right.
which
Yeah,
is
yeah.
0.002?
Well, is it two-sided? Is it, or does that matter?
No, ANOVA's always right-sided.
Oh, you're right. You're right. Wait, it is always right-sided. So does it mean,
So that's we have to divide it.
or does it already give us the answer like that?
You don't ever have to divide for the ANOVA.
Because it's just as it should be. It's already figured out.
Yeah,
Considering.
because it's the right-sided. Hold on, where did it go?
So yeah, it's always right-sided. It's always positive. It's never negative.
And you never divide the area in the tail.
Nope. Never. I have that underlined, so that means it's important.
Okay.
So, I don't have the other applet
Okay.
bookmarked, so I only have the first one.
So which best expresses the conclusion? The level of significance of A equals 0.05. So it's smaller than that.
So P is low.
So
What was
reject
the-
the null.
What was the p-value?
So the P is
0.002.
0.002.
Oh, okay.
Mm-hmm. So since it's lower, then there's insufficient evidence.
Yeah.
No.
Well, I was thinking there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups.
Yeah.
Right?
Yes.
The second option?
See, that takes me back to that number 9 where we were talking about sufficient or insufficient, whether it was lower or not.
Mm-hmm.
Yeah.
But see here, when you state it this way, it's pretty clear that since the p-value is low and we reject the null, that means that there's sufficient evidence to say it's otherwise than the null. So to me, that would say that 9 should be. It's statistically significant if the p-value is less than A.
That makes sense to me.
Wait, are you talking about number 9 again?
Yeah.
Uh,
I mean, we can still ask the tutor about that one, but to me, that kind of confirms that one.
Oh.
Okay.
Now we've got to open another data file for the last group of questions.
Of course we do. Did we already? Oh, hold on. I'm not down low enough. Sorry. Like, wait a second. I already had that one open. We're on 24, right?
Yep.
What are we opening? Direct flight costs.
Mm-hmm.
Fantastic.
So we read it while you're opening it.
Yeah.
The pressures of supply and demand act directly on the prices for an airline ticket. The seats available on the plane begin to fill and airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. The study was undertaken to determine if there's a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared to a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded on each scheduled flight 90 days in advance, and then again 14 days in advance. Perform a hypothesis test to determine if there's a difference in the cost of the non-stop flights when the tickets are purchased 14 compared to 90. Use a level of significance of alpha equals 0.10. Open the data file and answer the question. So the correct hypothesis test would be if those are dependent.
Yeah, they are.
Mm-hmm.
I'm going to say yes.
For a second, I started to think maybe it was ANOVA because of all of the different places you can go, but we're not comparing them individually. We're just comparing the 14 days to the 90 days. So.
Yeah.
Are we comparing the cost?
Uh-huh.
So then, do we need to